Hello friends, welcome to my channel. Do you know that along with making die projects with this Arduino Uno, we can also use it to measure DC voltages, right? So in this video I will show you that how we can measure voltages with Arduino Uno, and I will show you the program for this circuit also. So let's get into the video. Now there will be two cases for this project. The first case is for less than or equal to 5 volt and other case for greater than 5 volt. So I will show you the Arduino program and the circuit for both the cases. So let's start from the first case. So let's measure the voltage of this battery in the multimeter. So this red wire is for the positive terminal and brown wire is for the negative terminal. And you can see in the multimeter it is coming out to be 6 volt, right? So Arduino cannot handle 6 volt directly, so we will use a voltage regulator IC which is LM7805. So it will step down the voltage. So middle leg is representing the ground, left leg is the input voltage, and output is representing the right leg, right? So connect the red wire to the left leg of the IC and brown wire to the middle terminal of the IC. And take two more jumper wires, connect the positive lead on the output of the IC and brown to the middle of the IC. Right? Now let's measure the voltage of the output. So you can see in the multimeter it is coming out to around 4.5 volt, right? So Arduino can handle this much voltage, 4.5 volt, which is less than 5 volt, right? So connect this positive terminal of the output to any of the analog pin, like pin number A0, and this ground will be connected to the ground of the Arduino Uno. Now you may ask why we are connecting the positive terminal to the analog pin and not to the digital pin, because the voltage level can only be read by analog pins only, and digital pins cannot read the voltage level. It will only show that there is voltage or not. So 0 will represent that there is no voltage and 1 will represent that there is voltage. So if you connect the positive terminal wire to any of the digital pin, it will show that there is voltage or not, right? So that is why we are connecting this positive terminal of the IC to the analog pin. Now let's understand that how Arduino is able to read the voltage levels. So Arduino has onboard 10-bit ADC. ADC means analog to digital converter, which is linear in nature. Although we need to connect the positive terminal of the battery to the analog pin, but while performing calculations in the program, we need to convert those voltage levels into the digital values, because the Arduino can read only 0 and 1, right? So this ADC can represent total 1024 values starting from 0 to 1023. So these are the analog readings. So ADC maps the voltage level from 0 to 5 volt into the analog readings 0 to 1023, right? So the resolution of ADC will be 5 divided by 1024, which comes out to be 4.88 millivolt per reading. Okay, so 0 will correspond to 0 volt, 1 will correspond to 4.88 millivolt, and likewise 1023 reading will be corresponding to 5 volt, right? And linear means the graph will be straight line. You can see 0 to 5 volts and 0 to 1023 analog readings. So the graph is linear. So this means the ADC is linear in nature, right? Now let us move on to the program of this project. So this is the program for the first case in which we are measuring less than or equal to 5 volt, and we have defined the analog pin as pin number A0, and reference voltage is defined 5 volt, right? And ADC value is initially set to 0, which will store the analog values 0, 1, 2 and all the way up to 1023. So total of 1024 values, and voltage is initially 0. And in the loop function we are reading the analog state of analog pin and storing that state into ADC value variable, and voltage is calculated using this formula. So voltage is equal to ADC value times reference voltage divided by 1024, right? And we are printing that voltage on the serial monitor. So let's upload the program in the Arduino Uno and let's see what we will get in the serial monitor. So the program has been uploaded, and in the serial monitor you can see the voltage is coming out to be around 4.3 or 4.4 volt, right? Which is exactly the same that we were getting in the multimeter. Now if I change this analog pin to digital pin like pin number 7, and don't forget to connect the positive terminal of the battery to the pin number 7 in this case, and change this analog read to digital read because 7 is a digital pin. And now let us also print the ADC value on the serial monitor. Now let us upload the program in the Arduino Uno and let's see what will happen in the serial monitor. You can see the ADC value is coming out to be 1 and voltage is 0, because when you connect the positive terminal to the digital pin, it only shows that voltage is there or not. So 1 represents that voltage is there, but it cannot directly read the voltage level. That is why it is showing voltage is equal to 0 volt. So for measuring the voltage, you must have to connect this positive terminal of the battery to analog pin, right? So that is the difference between connection between analog pin and the digital pin. Now let's discuss the case number 2, where we will measure input voltage greater than 5 volt. So we will make use of voltage divider, right? So this is the circuit diagram for the voltage divider, and V out is the voltage that will be applied to analog pin of the Arduino Uno, okay? And V out is this much voltage from the ground level, and V in is this much voltage. So these are the formula for the voltage divider circuit, right? And V in my case is 11.7 volt. You can also take higher than that. And V out is 4.5 volt. You can also take it as maximum 5 volt, but for the safety purpose I am taking it as 4.5 volt as a previous case. So while calculating R1 and R2, these came out to be in my case 29 kilo ohm and R2 as 18 kilo ohm, right? So now let's discuss the circuit diagram for this case. So for the case number 2, I am making use of two batteries to have a voltage greater than 5 volt. And you can see I have connected these two batteries in series. So this brown wire is a negative terminal of this battery, and this blue wire is a positive terminal of this battery. So now let's measure the voltage level of this series circuit. So in the multimeter you can see the voltage is 11.63 volt, right, which is higher than 5 volt. Now for the R1 and R2 I am making use of 4 resistors, right? So I could not find a single resistor of value 29 kilo ohm, so I am making use of 3 resistors in series which are together forming R1, that means 29 kilo ohm, and the single resistor is of 18 kilo ohm. So now connect this positive end to this section and this black wire which will act as a ground on this last point, right? Now in the circuit diagram I have shown you that we will take out a wire from this section which will be connected to analog. So take two jumper wires, connect one end on this point and other end on this ground, right? So this positive end will be connected to analog pin of the Arduino Uno, and this brown wire will be connected to ground. So this is a complete circuit diagram. Now let me also show you the voltage level at this resistor. So in the multimeter you can see the voltage is around 4.2 volt, which is almost similar to 4.5 volt, right? Now let's move on to the code of the circuit. So this is the program for the case number 2, in which we will calculate greater than 5 volt. So everything is same as the previous code, right? And we have also defined R1 and R2 values. So and these values are in ohms, okay? And in the loop function, these two lines are same as the previous code. Let me show you, right? So voltage is replaced with the variable V out, and V in is equal to V out multiplied by R1 plus R2 and divided by R2. And we are also printing all the values, ADC value, V out, and input voltage. Now let's upload the program in the Arduino Uno and we will see what values we are getting in the serial monitor. So you can see V out and V in values are being shown here, and V out is approximately the same that we are getting in case number 1, and V in is also matching with the original values, which is 11.44 volt. So if you learned something new from this project, subscribe to my channel and share this video. And if you want some add-ons on this project, let me know in the comments. We will meet with a new project. Till then, keep learning.